Okay, this is copying a line segment. Just to make sure I'm consistent, I want to make sure I read the directions as they appear on the screen for you. In copying a line segment, the first thing you want to do is draw a ray below line AB and label the endpoint X. So I'm going to label the endpoint X here. Draw a ray. We're not measuring the length at all, because that's going to be in the next step. Second thing it says, place the needle of the compass at A and draw an arc that crosses B. So I'm going to place the needle of the compass at A so that it crosses B. So I have to extend until it hits B. I'm going to go a little above, and then I'm going to just draw an arc using the needle as the pivot point. Next thing it says, place the compass needle at point X. Keep the compass opening the same. So do not change the distance. Do not bump it or condense it in any way. We're going to draw an arc that crosses the ray that we just created. So needle is at point X. Draw an arc that crosses the ray. Done. And we're going to label the point where it intersects. We're going to label that Y. The last thing we're going to do is going to erase the excess. Here, here, the arc and the past the actual point. So we're going to label this endpoint Y. And without using a ruler, I just copied a line segment. Okay. We're going to be copying an angle. So first thing it says draw a ray and label the endpoint P. So I'm going to draw a ray, labeling the endpoint P. And we don't really care about the length of it, so there's my endpoint P. Next thing we're going to do is I'm going to place the needle at A of my compass. Draw any size arc that crosses both rays of A. We're going to label the points where they cross the arc. We're going to label them B and C. So, do not do it out here because it's not going to cross both sides of the angle. So you want to pull it in so that you know it's going to visually cross both sides of the angle. And then you draw an arc, keeping your needle at A. We'll label these B and C as our points of intersection. Next thing it says, place the needle at point P, keeping the compass opening the same. Draw an arc that crosses ray P and label the intersection point Q. So, just again to make sure, I've drawn this arc here, I've labeled my two intersection points. I'm not going to take the compass and change the distance between the needle and the pencil. And I'm going to transfer it over here and draw an arc. We're going to label that intersection point Q. Okay, so next it says place the needle at B, change the opening of the compass so that the pencil touches C. So, placing the needle at B, opening the compass so that it touches point C. So basically we are measuring the distance between B and C. Once I have this, so keeping the same opening, we're going to place the needle at Q, and we're going to draw an arc that crosses the arc passing through Q. So again, we measured the distance, not changing the distance, we place the needle at Q, and just draw an arc that intersects the arc that we just did. After that, label the point where it crosses R, and then you draw a ray from R to P to complete the angle. I've copied the angle. We're going to be creating an angle bisector, BQ of angle ABC. So we're given angle ABC. First thing we have to do is we're going to place the needle at B, which is the vertex, and draw an arc crossing both sides of the angle and label the points where it crosses, points X and Y. So, I have here, extended, you can be out here, it doesn't matter as long as it crosses both sides of the angle and you keep your needle firmly planted on the vertex of B. Draw an arc, it crosses both parts. We're going to label this X and Y. Now, it says place the needle on point X and draw an arc in the interior of the angle. Out here is the exterior, so the interior, think of this as a mouth. It's inside the angle. I'm going to keep the distance the same, so I just drew the arc here, so all I'm going to do is I'm going to transfer from X, draw an arc in the interior. Next thing, I'm keeping the compass opening the exact same, and we're going to do the exact same thing from Y. These two arcs intersect. Let's do that. We're going to label that point Q. And then we can draw a ray that goes from B through point Q. And that's our angle bisector. Now, an important thing that you need to have is you need to have the notation that indicates that this is an angle bisector, which means you need to have a dash mark and a dash mark here to indicate that the angles are congruent. So, I'm going to erase the excess just to make it a little bit neater. And there's our angle bisector. Alright, next thing we're going to do is create a midpoint, and it's going to bisect line segment AB, so I have line segment AB given here. We're going to place the needle at A and create an arc above and below AB. The thing that you have to make sure of, it has to go past the halfway point of the segment. So if we know this is the entire length of the segment, I eyeball it, and I say this is about halfway, so I'm going to go a little past halfway. Okay? We're going to do an arc above and below. Keep your needle firmly planted on A, the endpoint A. Next thing, I'm using the same opening, so I'm not changing the opening distance. And we're going to place the needle at B, create an arc above and below that intersects the arcs from step 1. So, or from the previous step. So I'm placing the needle at B, above and below. These intersect. These do not, so that means the arc that I made over here on top, I have to extend so that it does intersect. Next thing, grab your ruler or your straight edge. We're going to draw a line that connects both sets of arcs. Here. And I find out where my midpoint is. So there's my midpoint, M. I can erase my excess. And since this is the midpoint, that means I know that AM's length is equal to BM's length. I also know that AM's segment is congruent to BM's segment. The thing is, this I know, but I have not indicated it here, so I need to have notational dash marks. So I have a dash mark here and a dash mark here to show that those are congruent. Okay, we are asked to construct a midsegment DE of triangle ABC so that DE is parallel to AB. So we have AB is here, that means the midpoints I have to find are between AC and BC. So what I'm going to do, I'm going to do AC first. I start at one of the vertices, one of the endpoints, go past the halfway point. This is the entire length of AC. So past the halfway point, arc above, arc below. Problem is, we don't have above and below, we have upper right, lower left. Do not change the distance. Go to the other endpoint, arc above, arc below, or arc to the left, arc to the right. We're basically finding the midpoint and doing this a bunch of times. Connect the arcs, intersection of the arcs. Find your midpoint here. That's going to be D. And I erase my excess. The most important piece of advice I can give during these constructions is label as you go. Once you have the labeled point, label the congruent segments. Okay? So now let's do BC's, midpoint. So I'm going to do from C again. The entire length of BC is this, but again I have to go past the halfway point, just visualize it. Above and below, or arc below to the lower left, upper right. From the other end point, above and below. And again, you want to make sure that the arcs intersect. In both cases, they do not intersect for me, so I have to extend them. Extend them here. So I have my intersection here, grab your ruler again, connect the two intersections. There's your midpoint. That will be E. Double dash mark, and erase your excess, or erase your excess and then do your notation. It really doesn't matter. Just as long as you have the notation and you're erasing your excess, so that it doesn't get too complicated. All right. Last but certainly not least, we're going to create our midsegment just by connecting the two midpoints. Okay. And I have, since this is D, this is a midsegment, two things that I know. 1/2 of AB's length is going to equal DE's length. That's one. Two, I also know that this DE line segment is parallel to AB's line segment. I have my notation. This is a midsegment theorem, and I'm done.